Hello and welcome to Lesson 8.1 for 4th grade math. We're on page 270 today and we'll be cracking a number story code. I'm going to walk you through some quick strategies regarding how to take a big story problem and break it down into something a little more digestible to help us solve a code at the end of our lesson. So let's dig right in. Every year, Blythe Elementary School holds a secret contest. Each class is given 7 problems about the school. The answers are part of a code that tells where a hidden prize is located. The class that cracks the code and gets to the location first wins the prize. Help Mrs. Fitzgerald's class win the prize by solving the problems below and cracking the code. Okay, so we're going to have 7 questions we're answering today, or today and tomorrow, depending upon how you break this up. And all of our answers are going to lead us to question number 8, which is actually solving the code. And we'll go over that a little more closely in a moment. But first, let's take a look at question number 1. The school custodian, Mr. Granger, brought every pencil he found on the floor this week to the school lost and found. At the end of the week, there were 126 pencils in the lost and found. Mr. Granger said he found 3 pencils in one classroom and 5 pencils in each of 3 classrooms. He then found an equal number of pencils in each of the 9 remaining classrooms. The question is, how many pencils did he find in each of those 9 classrooms? So it's a lot of numbers being thrown out at us at one time. So this is where it becomes pretty important for you to have a separate piece of paper. It could be a scrap piece of paper, like the back of a paper we're not using anymore, or it can be a notebook. Really anything works. So what we need to do is go back, reread our story problem, and start marking down the data that we have. So I noticed this first sentence doesn't really give us a lot. It just tells us that Mr. Granger is a custodian. So let's jump ahead to the second sentence where it says that at the end of the week, there were 126 pencils in the lost and found. So Mr. Granger found, that's a good piece of information to start with, 126 pencils altogether. After all of his custodial work, he came up with 126 pencils. Now let's talk about how they were broken down. Mr. Granger said he found 3 pencils in one classroom. Okay, so I'm going to say one class had 3 pencils. If you can hear scratching in the background, that's my cat trying to get in. 5 pencils in each of 3 classrooms. So the key word here is each. So that means there's one class that had 5, then another class that had 5, and then the third class that had 5. We may want to think of a shorter way of writing that for the next group. We'll see. And so our question is, he tells us, or the story tells us, that he found an equal number of pencils in the remaining 9 classrooms. So they want to know how many pencils were found in the last 9 classrooms. So let's take a look at the information we have. There's 126 pencils overall. One classroom had 3 pencils, and then 3 other classrooms had 5 apiece. Okay, so my first thing I might want to do is figure out how many pencils we've already accounted for. Like I said, they already told us how many pencils were in these first 4 classrooms. One classroom had 3, and then another classroom had 5, another classroom had 5, and another classroom had 5. So let's do some quick counting. And 5, 10, 15. Now let's add 3 to 15. And I believe that should give us 18 pencils accounted for. And when I say accounted for, that means like we know where they were. Okay, they told us where they were found. 18 pencils accounted for. So here's the trick. If there's 126 total and we know where 18 are. That means there's a lot we still don't know about. So here's a trick I'm going to show you. Let's take the total number and subtract the amount that we can already account for. Let's take that 18 away because we already know where those 18 are. So some quick subtraction here. Can't do 6 minus 8, so we need to borrow. You can do 16 minus 8 though. That's 8. 1 minus 1 is 0. 1 minus nothing is 100, or it's 1, for a total of 108. So now here's the next step. We know there's 9 classrooms left, and they found an equal number in each of those 9 classrooms. And we have 108 pencils left. So this means we have 108 pencils that were spread evenly throughout 9 classrooms. So can you think of a way that we can find an equal amount of pencils in 9 classrooms? Is there a way we can divide that up somehow? And I think I just may have given it away. I didn't mean to, but it was in my last sentence. And to divide something or to split something equally, we can divide. So why don't we try that here today? Let's take 108. That's the amount of pencils we have left. And let's divide by 9. Now, I'm usually a traditional long division person. That's how I was raised. But we've been on a partial quotients kick lately, so I'm going to use partial quotients to solve this problem. So the first thing I want to do is think, what can we multiply 9 by that gets us really close to 108? Just something really easy. And usually I think of 10s or 5s. And can you do 9 times 10? I think you can. We know 9 times 10 is 90, right? So 9 times 10, we'll put a 10 over here, equals 90. So we took a pretty big chunk off there. And a lot of you might be able to do 9 times 11, which is 99. That gets you really close. But this will still bring us right to the edge. Borrow. 10 minus 9 is 1. And I bet you guys can tell right now, what can you multiply 9 by to equal 18? I know 9 times 2 equals 18. And this is partial quotient division. The cool thing is you get to kind of choose your own path. You can take off a big chunk at the start or a small chunk, it doesn't really matter. So depending how skilled you are at multiplication, this can be a very quick process or it can take a little extra time. But either way, we have just found out that if you take 108 and you divide it by 9, in this case it's going to be the 9 classrooms, we end up with 12 with nothing left over. So that means, guess what? We just found our first answer. So how many pencils did he find in each of those 9 classrooms? 12. Now, if I can show you down below, let's flash forward to question number 8 so I can show you how we crack this code. So I'm going to summarize this without reading. Basically, you need to put your answers for each of the problems in these rectangles in order. So we know for problem number 1, we just got an answer of 12, right? So put 12 in here. But to crack the code, this 12 means this first letter will be the 12th letter in the alphabet. So A1, B, A, B, C, D, E. I can't count and say my alphabet at the same time. A, B, C, D, E, that's 5. F, G, 7. H, 8. I, 9. H, I, J, 10, right? K, 11. Then L, this should be our 12th letter, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means the first letter in our code is going to be the 12th letter in the alphabet, which as far as I can tell, unless I made a mistake, is the letter L. So you can go ahead and put your first letter into your code breaking system. Now, I have a little time left, so maybe I'll get you started on number 2. And really, a lot of these problems, again, are just going to be about taking your time, writing out the information you have, and solving it one piece at a time. So let's take a look. I don't know if I can finish it, but I can get you started. Mr. Granger walked by the cafeteria after lunch, and he saw that the chairs around 9 tables had been moved. He saw 12 chairs at each of 5 tables, 5 chairs at each of 3 tables, and 6 chairs at 1 table. He moved the chairs so that each table had the same number. So how many chairs did he put at each table? That's what we need to figure out. But before we can do that, we need to figure out how many chairs we have all together, right? Because we don't know how to split this up or divide it equally if we don't know what we're starting with. So here's how I'd begin this problem if I were you guys. Let's find out how many chairs we have. So we'll start by noticing that 5 tables have 12 chairs apiece. These tables must be kind of big, I'm guessing. So here's a trick for this. You could do 12 plus 12 plus 12 plus 12 plus 12 5 times. Or, you may have just heard me say it, we can literally do 12 times 5. This will be the quickest route for us if we like. And the traditional route would be to say 5 times 2 equals 10. And we need to carry, just like addition, carry the 1 from 10. And then we'll do 5 times 1 is 5 plus 1 is 6. So 12 times 5 is 60 chairs. So this part is good. We just did 12 at 5 tables, and that might be the hardest one we have. Take a look at our next chair situation. 5 chairs at each of 3 tables. Cool. So 5 times 3. What's that equal? That should be automatic for a lot of us. What's 5 times 3? 5, 10, 15, right? And then 6 chairs at 1 table. I like how this got easier the further along we went into our sentence. So that's literally just going to be 6 chairs at 1 table. 6 one time, which is still just 6, right? So it looks like we have all of our tables represented right here. And what we need to do is put them all together. And if you're like me, I can't add sideways super well, laterally. I need to add vertically. So you may want to take the totals from each of these subsets and rewrite them like a vertical addition problem. Vertical means up and down. That's why if LeBron James has a excellent vertical, it means he can jump very high into the air. And we're going to do 60 plus 15 plus 6. Okay, what's 0 plus 5? It's 5, right? What is 5 plus 6? It's like 5 plus 5, but 1 more than that. So 5 plus 5 is 10, plus 1 more is 11. Carry that 1. And 6 plus 1 is 7, plus the extra is 8. Oh no, this is going to be beautiful for my people who know their multiplication tables. So we just found out that we have 81 tables, and I might leave this very last part to you. I'll tell you what you're going to need. Let's take a look at the problem. So this was the breakdown of all the chairs that we have. Oh no, I've made a mistake. I called this tables. This is chairs. So we have 81 chairs is what we found out altogether. And we want to know, I think, let me double check this. We want to know what would happen if we moved the chairs so that each table had the same number. Well, they told us here that there's 9 tables total. So you need to figure out, with 81 chairs, how can you split them evenly between 9 tables? And do you want me to, oh gosh, I'm gonna give this one away. But another way to think about it is basically someone might say, hey, there's 81 chairs. Can you divide them equally between 9 tables? So listen to that sentence one more time. You need to take the 81 chairs, divide them equally between the 9 tables, and that will give you your answer for number 2. If you have any other questions, let me know directly and I'll walk you through the rest or whatever you need. So long.